Imagine this. Your design intuition, that gut feeling for what works. Imagine it gets amplified.
Like a superpower.
Exactly. Fueled by hard data, revealing things you wouldn't normally see, opening up new creative paths.
And that's not science fiction, is it? It's happening now.
It really is. Welcome to the deep dive. Now, this session is specifically for you, the learner, someone who wants to get up to speed, quickly really understand something, but without feeling totally overwhelmed.
Yeah, we're aiming to pull out the absolute key stuff from some material we've looked at on design, data, and this thing called computational design.
Right. So our source material includes parts of a YouTube lecture. The title translates roughly to Computational Design for First-Year Design Students, Design and Data in the Coming Era.
It features Igorian, who works at a data company. And we also have a briefing doc that boils down the main points.
Now, the lecture was aimed at students in Korea, but the core message, it's universal, isn't it?
Absolutely. This convergence of design and data, it's happening everywhere. That's our focus today.
Okay, so our mission is pretty clear. Understand why data and coding are getting so important in design, and unpack computational thinking, what that actually means.
And give you some solid takeaways, some practical ways to think about navigating all this.
All right, let's get into it. The sources really paint a picture of a world just drowning in information, technology, everywhere.
It changes so fast. Things that felt revolutionary to us, well, the next generation just takes them for granted, like the internet or maybe the metaverse soon.
Yeah, and that leads to a really interesting point about competition.
Yeah, the lecture mentioned this. It's not just about the people sitting next to you in class anymore.
No,
Yeah.
it's potentially people who grew up, coding like it's second nature, like we use a web browser.
Which really raises the bar, doesn't it? The baseline skill set is shifting.
Definitely. And you just can't deny how much data is part of, well, everything.
Right. The news we see, how we work, how we socialize.
It's all data being generated, crunched, used.
The speaker in the video had a great line, paraphrasing the translation. Ultimately, it's all about data.
Yeah, he said something like, even if the names change AI, big data, whatever, it boils down to the same questions.
How do you collect it? How do you process it?
How do you find the insights? And then, crucially, how do you apply it?
So connecting the dots, the speaker is essentially saying data is a new kind of fundamental material for designers.
Like clay or pixels or code, now data.
Exactly. Which means the essential skills are evolving too. It's
Yeah.
about data collection, processing, finding those insights and putting them to work.
And these aren't just for data scientists anymore. They're becoming core design skills.
Yeah.
Now, something that really jumped out at me was the bit about language and how we process information.
The historical progression, that was cool.
Yeah. Starting with spoken language, which can be, a bit messy.
Ambiguous, yeah.
And then moving to written language, which allowed for more precision, more permanence.
It's a great framework for thinking about where we are now. Our specialized knowledge, like your design major. That's a kind of language for solving problems.
Right. The example was urban decay, wasn't it?
An architect sees it one way, a politician another, an activist, a lawyer. They all use their language to analyze and tackle it.
So what's the next step in that evolution, according to the source?
It's coding. It's presented as the next critical language for boosting how we handle information and solve problems.
And it's not just about programming, is it? It's deeper than that.
No, it's about the thinking behind it. The speaker says something like, the key is that coding, computational thinking, it's a mindset for tackling problems systematically.
Which naturally leads to, okay, how does it do that? What is computational thinking?
The lecture defines it pretty simply. Thinking like a computer to solve complex problems.
Not becoming a robot, though.
No. Adopting that structured, logical approach.
And the speaker breaks it down into 4 main parts. First up, decomposition.
Right. Taking a big, scary problem.
And chopping it into smaller, manageable bits. The example was just buying something tasty when you're hungry. Sounds simple, but...
There are loads of smaller decisions and steps involved, right?
Yeah.
Where to go, what kind, how much money.
Exactly. Then number 2 is pattern recognition.
Seeing the repeating elements within those smaller problems.
Why is that useful?
Efficiency. If you spot a pattern, you can reuse a solution, maybe reuse some code. It saves time.
And frees up brain power for the creative stuff, the human stuff.
Precisely. Third component, abstraction.
Which is about simplifying.
Yeah, boiling it down to the essentials. Filtering out the noise and focusing on what really matters for solving this part of the problem.
Okay, and the last one?
Algorithms. creating those clear step-by-step instructions.
The recipe for solving the problem.
Exactly. The speaker had a quote about the core of algorithms being, what was it? Sequence, branching, and repetition.
Yeah,
Yeah.
sequence, doing things in the right order, branching,
Right.
making logical decisions like if this, then that.
And repetition, doing things over and over when needed.
That makes it sound much less intimidating. Sequence, logic, repetition.
Yeah, the analogy was good too, trying to explain to a non-designer exactly how to create, say, a motion graphic. You have
Yeah.
to break down every single click and drag.
Okay, I get that. It's about precision.
Precisely. Which brings us right to why this matters so much for designers now.
The sources are clear. Data isn't just an afterthought anymore. It's a core design material.
Right from the start,
Yeah.
along with all the traditional tools and methods.
And this is all happening in the context of the fourth industrial revolution, right? Software is key.
Software is the main tool for processing all this data. The lecture mentioned standing on the shoulders of giants.
Meaning software lets us tap into all the knowledge humanity has built up super fast.
Yeah, think about the history. Knowledge on papyrus, stone, then books and libraries.
And now digital, accessible almost instantly. And computers process it way faster than we ever could.
The speed difference is just astronomical.
And the economic side is huge too. These tech companies built on data and software. Their value is immense.
Often bigger than the GDP of whole countries. It shows where the power lies.
And within design itself, software is just essential now. The speaker called it a near-total dependency.
And what is software doing, fundamentally?
Processing data. That Photoshop click example was good. One click triggers complex data manipulation underneath.
Right. So the benefits for designers getting into coding. The sources list things like, well, boosting creativity by automating the boring stuff.
Making designs that are more functional, more responsive maybe.
Yeah, optimization becomes much more powerful. And it opens up totally new ways of designing driven by data.
But there are misconceptions, right? It's not about ditching traditional skills.
Now it's a complement, an enhancement.
And you don't have to become a full-stack developer doing everything alone.
Not necessarily. It's more about applying that computational thinking strategically to design problems you face.
Okay, so that's the synergy, data and design, computational design.
Yeah. The lecture frame design is basically a series of decisions.
And data can make those decisions much more informed, more explicit.
And that data can be anything, really. Urban data, image data.
Using machine learning, maybe?
Could be. Or even personal user data. The speaker stressed the role of algorithms in actually using this data effectively. You need the methods to process it.
And we get some cool concrete examples, too. Architecture.
Environmental simulations, sun angles, airflow, optimizing building placement, traffic flow, that kind of thing.
Interface design that responds to body movement.
Generative design, creating forms based on rules you set up.
Interactive installations. VRAR, motion graphics driven by data.
Yeah, lots of applications. All highlighting this growing need for people who get both sides.
The design vision and the computational know-how. Bridging that gap.
Those people are becoming super valuable.
So for you, the learner, thinking, okay, where do I start? Any practical advice from the sources?
Yeah, one suggestion was to start with coding languages relevant to tools you already know.
Like JavaScript for After Effects.
Or Python for 3D software like Maya or 3ds Max. It builds on what you're familiar with. Makes sense.
That's smart. What else?
Reframing math was another one. Don't think high school calculus necessarily.
Think of it as a tool for visualization, especially 3D geometry.
Exactly. The quote was something like, see math as another lens for visualizing design ideas, shapes, forms. Takes the fear out of it a bit.
I like that. And thinking about software differently, too.
Yeah, instead of just brand names, think about the type of data it handles. Vector, raster, surface, polygons.
Gives you a deeper understanding of what it's actually doing.
Right. And, of course, use the resources. The YouTube channel mentioned Code for Design NJ channel and the briefing doc. They're there for focused learning.
Okay, skills are one thing, but mindset seems huge here, too.
Absolutely crucial. The lecture really pushed finding your own passion, not just chasing trends.
That intrinsic motivation keeps you going when it gets tough.
And embracing experimentation. Seeing failures not as dead ends, but as, what was the phrase?
Periods of energy compression. A bit poetic, but I get it.
Yeah, like you're building up potential. The quote was like, don't give up when it's not working. That's often when you're about to figure something out.
That's encouraging. Also, developing deep expertise.
Right. Better to be really good at a few things than just okay at many. Find your niche, build that advantage.
And connect the dots, link your past experiences, your existing knowledge with these new skills.
That's where unique perspectives come from.
Yeah.
And taking the long view, this isn't an overnight thing.
No, skill development takes time. And there was a point about defining being good.
Yeah, it's a partly external validation, sure, but also that internal drive, always wanting to improve.
And asking questions, engaging actively.
Definitely. Finally, the lecture kind of zoomed out to the future, reminding us how unpredictable it is.
Examples of old predictions about the year 2000 that were way off.
Yeah, and the anecdote about people dismissing the idea of an iPhone-like device back in 2008, right before it changed everything.
Shows that progress isn't always linear. Things can change fast and unexpectedly.
So the encouragement is to think broadly about how your design skills might evolve, maybe in ways you can't even imagine yet.
Okay, so let's wrap up this deep dive. Key takeaways. Data is becoming fundamental in design's future.
Right. In computational thinking, enabled by coding, is the way to work with it effectively. It's the toolkit.
For you, the learner, getting a handle on these skills isn't just about keeping up. It's a real strategic advantage.
It lets you push boundaries creatively and functionally.
So we definitely recommend checking out those resources we mentioned, the Code for Design and J channel on YouTube.
We'll link it in the show notes, lots more there.
And revisit the briefing document for those detailed insights and more links.
And maybe just chew on this final thought. As technology keeps accelerating, how will you specifically use data in computation?
Not just to follow where design is going, but to actually help shape it, maybe even redefine what design can be.